So that's recording.
Okay. How's everyone doing?
Good.
All filled up?
Yes. We're ready for the icebreaker.
I'm awesome, Posh.
Okay, so I'm going to give a brief intro of making robots. It's going to be very, very basic, and I somehow got out to my presentation. Oh, this is going to start. So it's going to be quite brief. It's not going to be too detailed. It's just going to give you a sort of idea of the design process of making a robot. So the first thing that with any robot is, what is the robot's purpose? You need to find some type of purpose, objective, something like that, that your robot is going to do. So, will it fetch a beverage from the fridge?
Yes, please.
Will it chase your cat around?
Yes.
Or maybe
At the
even
same
torture
time.
it? Yeah, that's meant to be striked out for some reason, and it's not. Oh well, continue on, I suppose. Perhaps it will cruise down the streets while blaring annoying music. And perhaps it could fly into a storm and search for someone. Really depends on what you think of and what is possible on your budget. So the things that you need to consider when you're doing a robot is, how's it going to move? So mobility. How's it going to sense the world around it? So sensors. How is it going to communicate or give feedback to you? And what is its brains going to be? So, mobility, how is your robot going to move around? Well, what is suitable for your application? Is it in a tight space? Is it in a nicer open space? Is it having to search around a lot? Could it be a flying robot, for example? Flying robots have to be lightweight to be able to fly, but they could also be dangerous, especially in closer spaces, with spinning blades and props. Planes can do nicer long ranges, but they can't really hover around, so they can't do small spaces. Whereas helicopters and multi-rotor copters can work in small spaces easily enough, but they don't have as good as range as planes. Of course, the most obvious thing that people think with robots is wheels and tracks. So gearing the motors down allows a slow but heavy robot to move around. And they also are safer in close environments if the moving parts have been hidden from view. And if you need it nice and simple, you can make it work exactly the same as a car with a single motor and servo, steering some wheels at the front. But it also means that your turning circle won't be as great. There's another option is you give your robot legs, so it can walk around its environment. Like the wheeled robot, it can take a heavier load, but probably not as heavy as you could do with just some basic wheels and tracks. So you can also, it's also more complicated than doing wheels and tracks, as you have more moving parts and you need to sequence things. And if you have independent legs, you can actually get it so that it can walk over larger objects compared to just using some tracks or wheels. So we perceive the world with our eyes, our hearing, our sense of touch, that sort of thing. We feel the world, we know it's pretty cold in here, we can see that there's a light on. These are sort of things that a robot needs to imitate to be able to do things and achieve this objective. Robots can hear simply with microphones. It's nice and easy, and more microphones means that if a sound comes from a certain direction, it can actually measure where that direction is and move towards it. So 2 microphones, we have the 2 ears. Means that if I hear a click on my right, I know it's coming from the right, apart from the fact that my arm is here. So microphones, simple human sensor, but it's a little bit hard to process that. So making the robot being able to see could just be a simple webcam. But processing that information could take too much for a low-powered brain that you pick for your robot. That's something I'll need to go into a little bit later on. But if you pick a too low-powered robot, too low-powered brain, you may not be able to process all the camera data that you want to, which will allow you to recognize objects. Another way to see is using something simple like light detectors, so that your robot can move towards a light source, or even just some distance sensors using either ultrasonics or something like an infrared detector, so that it sends out some type of ping and looks for a response. Once it gets its response, it can work out how far an object is from that sensor, and if you have the sensor moving around, you also can work out where that distance response is coming from. Another way of getting a robot to sense is for it to just rub up against things we feel is hitting on switches and buttons. It's a nice simple way, and it's one of the possible easiest ways that a robot will go up to a table, bump into the table leg will hit the switch, and then the robot will go back and move on. Buttons also make a great way of being able to provide feedback to the robot back, so you can get it to do something different. So if you poke the robot back, it can change its behavior as if it has a piece of sticky tape on its back. So if you can also give a robot a sense of balance. And the best sort of way is to use an IMU, which is an inertial measurement unit. So it can tell what way the robot is orientated, and you'll most likely find these sort of IMUs are found on robot aircraft rather than ground-based vehicles. And a knowledge of where the robot is itself can also be handy. So why not add a GPS receiver so it can wander down the street? So communication is important because you need to know what the robot is thinking or what the robot is doing. So a wireless transceiver, maybe just a simple wireless serial port link, can give you feedback on your own device, so that you know what it's going to do, and if it's doing something that you don't want, you can quickly power it off or something like that. A speaker also is a good way of giving you audio feedback. So it can play a buzzer, play a noise, or something like that, which means that you know what it's up to. LEDs, also another simple way of getting it working. And also another method of getting feedback is a visual method, and have a little screen on your robot which says, I'm going this way, that way, I'm about to blow up. So lastly, we come to the robot's brain. So without some type of brain to glue all these pieces together, your robot's going nowhere. It can't even be a good zombie. So most common way that people will do it is using some microcontrollers and write a piece of software to get the robot to do what they want. Some simple robots can be made with basic electronic components, such as resistors, capacitors, and transistors. And sometimes if basic electronics doesn't work, and microcontrollers don't work, then you need to design something custom, and you can do that in an FPGA to design your own microcontroller with all the features that you want. So other design choices for your robot could be, well, where's this robot going to get its power from? Is it going to be solar power? Is it going to be batteries? How are all the pieces going to fit together? What sort of chassis do you want to match your robot? Is there any components that you need to protect, as in, will it come in contact with water in the rain? And do you think you want to expand on your robot later? Because if you make a robot, do you have to rework the entire thing to be able to add one small feature? So, some personal robot projects I'm actually working on, and basically everything that's covered previously has been a part of this design choice. Is I'm building a small autopilot for a small helicopter and a plane, and that will hopefully be able to be entered into a search and rescue challenge later on. I also made a rotating webcam stand to allow me to check on the cats while I was on holiday. It was basic, simple, but effective enough that I can move it around and see whatever the webcam was saying. I also have a little project, the Raspberry Rover, which is a Raspberry Pi powered robot, and it allows me to chase the cat around the house, but going to be later being repurposed so that I can actually map out my entire house with ultrasonic sensors and a webcam. I'm also working on a 3D printer, RepRap Cruiser, and that'll allow me to learn more about 3D printers and also be able to make my own individual robot platforms in-house. And of course I'm designing a cheaper Raspberry Pi add-on board so that I can add it to the Raspberry Pi and make a small robotics platform that is very cheap and easy for kids to get into. Any questions?
We've talked about design questions during this event.
Yep.
Where would you go about sourcing componentry?
Depending on what you know, depends on sort of where you can go to get the components. Because you could go to a parts supplier which has all the raw parts that you need to build a robot. But if you wanted something where you didn't know too much about what part, you could go to something like SparkFun, Artifruits, etc. And they'll have a section dedicated to sensors, robotics, etc. Yep. I've mentioned the Raspberry Pi, but on my Raspberry Rover, there's actually a microcontroller that's using the Cortex M3 microcontrollers, and that is handling all the sensor interaction, display interaction, etc., while the Raspberry Pi is currently just a serial pass-through. So it's a expensive wireless adapter, really. I'm currently using just Wi-Fi, but for my UAVs, I'm actually going to be using 900 megahertz XP links, and I'll just use that as a simple serial link.
I imagine an Arduino board or something would probably work quite well as a brain as well.
Yeah. Arduinos, and basically any type of microcontroller board that you're comfortable with, they're a good robotics platform. And I did a talk at the last Barcamp at getting started with microcontrollers and briefly touched on that.
Is it worth mentioning there's hackerspaces in Melbourne?
It is worth mentioning. If there's a hackerspace, the community connected hackerspace, I believe that's correct. Hackermelbourne.org. If you're interested in doing robotics, but don't have the full knowledge on doing it, you can just go to the hackerspace and get help from people. So if you want help with interfacing with a certain type of sensor with your brain, then you can get someone's help and they'll hopefully be able to read the instructions, usually in the form of a data sheet, and they'll be able to help you interface it with that sensor. I think that's it.
That's Hack Melbourne, not Hack Melbourne.
Yeah, it's hackmelbourne.org.
Yeah. That was good, Johnny.
I love the way the two rooms tap at the same time.
They just copied.
They did, yeah, they have.
No.
It wasn't sound of you.
What's the sound of
They
my red
fought
clay?
applause.
Right, so in 4 minutes,